here we have to integrate tan inverse x, which is term of inverse trigo. So we can apply multiplication rule. I never like inverse trigo term, so I always prefer that we have to assume tan inverse x is equal to our new variable t, where t is belongs to 0 to pi by 2. So we can get x is equal to tan t. Now if we differentiate both the side, we will get dx is equal to differentiation of tan t, which is sec square t dot dt. So we are ready to modify our integration. Instead of tan inverse x, we have to substitute t, and instead of dx, we have to substitute sec square t dot dt. Now we are ready to apply multiplication rule. Your t is algebraic term and sec square t is trigonometric term. So if we go from the right hand side, we will get algebra first and then trigonometry. So we can say your algebraic term will be u and trigonometric term will be v. So according to formula, in first step, your u will be as it is. We have to integrate the second term, which is v, minus integration of product of differentiation of u, which is t, and integration of v, which is sec square t. Now let's simplify. T will be as it is, integration of sec square t will be tan t, minus integration of differentiation of t will be 1, and integration of sec square t will be tan t dot dt. So here your first term will be as it is, and in second term we just have to integrate tan t into 1, or we can say integration of tan t is log mod sec t was c. Now we get the integration in terms of t, so we should get our final answer in terms of x. So let's use our assumption to get the answer in terms of x. Our tan t is equal to x, or we can say x by 1. So let's use trigonometry. Let's assume this is your angle t. Now as we know, tan t is opposite upon adjacent. So this will be your opposite side and this will be your adjacent side. So hypotenuse must be under root of x square plus 1 square, say 1. So we can get the value of sec t by hypotenuse, which is x square plus 1 upon adjacent, which is 1. So we are ready to convert our answer in terms of x. Instead of t, we have to substitute tan inverse x, and instead of tan t, we have to substitute x, minus log mod. Instead of sec t, we have to substitute under root of x square plus 1 plus c. But this is not in your answer, so we have to simplify the second term. Instead of under root, we can say x square plus 1 whole raised to 1 by 2. And in further simplification, your first term will be as it is. And in second term, if we apply the property of log, this power will go in multiplication of log. So we get 1 by 2 log x square plus 1 plus c, which is given in option A. Ta-da! In this question, you have to integrate x into sine 3x, where x is your algebraic term and sine 3x is your trigonometric term. So in this MCQ, we can apply our shortcut. Let's say our first term will be as it is, and then space for the integration. Then we have to change the sign, so it will be negative. Differentiation of x will be 1. Then if we go further, then differentiation of 1 will be 0. So we don't have to worry about this term. Now let's fill the space by integrating sine 3x minus cos 3x upon coefficient of x, which is 3. Again we have to integrate minus cos 3x upon 3. So it will be minus sine 3x upon another 3. So it will be 3 square. plus c. So we get our answer in just one step. Minus of x cos 3x upon 3. Then minus minus become plus sin 3x upon 3 square, or we can say 9, plus c, which is given in option A. Tada! In this question, we have to integrate under root of 1 plus x square. We have second order polynomial in numerator. That's why we have to select the formula from here. Our question is in the form of a square plus x square. So we will use first equation. So its answer will be x by 2 under root of 1 plus x square plus a square by 2, or we can say 1 by 2 log mod x plus under root of 1 plus x square plus c, which is given in option A. Tada! જો ધ્યાન રાખવાની આ ફોર્મ્યુલા ક્યારે યુઝ કરવાની? ડિનોમિનેટરમાં સ્ક્વેર હોય તો, પણ આપણા સમમાં ન્યુમરેટરમાં હતું એટલે આપણે આ ફોર્મ્યુલા યુઝ કરવી પડે. બહુ જ ધ્યાન રાખજો આ બધા ફોર્મ્યુલામાં, હો, કન્ફ્યુઝ ના થતા. ચલો નેક્સ્ટ ક્વેશ્ચન પર જઈએ. In this question, we have to integrate x upon x minus 1 into x minus 2. We can apply partial fraction, but here we have one special format. So let's use shortcut to solve this MCQ. And here it is. Your a, which is coefficient of x in first term, is 1, and constant term, which is also 1. Similarly, from second term, we can get the value of c and d. C is coefficient of x 1 and d is constant term which 2. So its answer will be 1 upon determinant of 1 1 and 1 2 into, in first term we have to select the second factor. So constant upon coefficient of x log mod our factor, which is x minus 2, minus constant upon coefficient of x log mod our factor, which is x minus 1, plus c. If we solve this determinant, we will get 1. And to simplify our bracket, we have to use property of log. According to property, this 2 will go within the power of our term, which is x minus 2. So it will become x minus 2 the whole square minus log mod x minus 1 still remain as it is. Now here we get log a minus log b form, which can be simplified as log a by b. So let's write down our a, which is x minus 2 the whole square, upon b, which is x minus 1, plus c. Is your final answer, which is given in option B. Tada! भाई शॉर्टकट में खबर पड़ी. जो सिंपली શું કરવાનું, તમારે ડિટર્મિનન્ટ બનાવી દેવાનું a b c d. પછી અહીંયા આ d by c मतलब શું યાદ રાખવાનું? constant term upon coefficient of x log mod factor. Similarly, constant term upon coefficient of x factor log mod જે હોય. Here you have to integrate 1 upon cos x plus root 3 sin x. To simplify our function, let's multiply and divide by 2 in the denominator. So here we'll get 1 by 2 cos x plus root 3 by 2 sin x into 2. Now, you don't have to worry about this 2. Take it outside. And આપણે શું જોઈશે? જો tan x by 2 plus pi by 4 मतलब આપણે sec જોઈશે. sec જોઈતું હોય તો નીચે cos જોઈએ. હવે નીચે cos જોઈતું હોય તો આપણે શું જોઈએ? cos alpha plus cos beta ની ફોર્મ્યુલા થાય. Now, let's substitute the value of 1 by 2 and root 3 by 2. In first term, cos x will be as it is. We can say instead of 1 by 2, we can substitute cos pi by 3. Similarly, in second term, your sin x will be as it is, and instead of root 3 by 2, we can substitute sin pi by 3 dot dx. So here 1 by 2 will be as it is. In denominator, we will get cos alpha cos beta plus sin alpha sin beta, which is cos alpha minus beta. So our denominator will become cos alpha, which is x, minus beta, which is pi by 3 dot dx. Now we can say 1 upon cos x minus pi by 3 is simply sec x minus pi by 3 dot dx. And to get the proper answer, which is given in option, you have to apply integration of sec x is equal to log mod 10 x by 2 plus pi by 4. So let's say here we have log mod 10 angle by 2. That means x plus pi by 3 by 2. We will get x by 2 minus pi by 6 plus pi by 4 plus c. So here we get 1 by 2 log mod 10. This minus pi by 6 plus pi by 4 will become plus pi by 12 plus c. So here we get our final answer as 1 by 2 log mod 10 x by 2 plus pi by 4, which is given in option C. Ta-da! Here we have to integrate under root of 1 minus sin 2x. Whenever we have under root of 1 plus or minus sin x, then to simplify, we have to convert this one in terms of sin square theta, where theta is half of the given angle plus cos square theta, and sin 2x can be converted into 2 sin x cos x. So we will get a square plus b square minus 2ab form. Or we can say we have the perfect square of sin x minus cos x. So here square and under root can be cancelled out and we will get mod sin x minus cos x. But our x is belongs to 0 to pi by 4. So in this case, our cos x will be greater than sin x. So we can say in this situation, our mod sin x minus cos x will become cos x minus sin x, because cos x have a greater value. So integration of cos x will be sin x and integration of sin x will be minus cos x. So it will be plus cos x plus c. Ta-da! This is your final answer, which is given in option D. Here you have to integrate sin 2x upon sin 5x sin 3x. That means we need to get 5x and 3x in numerator, and for that we have to split 2x in terms of 5x minus 3x. So our numerator will become sin of 5x minus 3x, and our denominator still remain as it is. Now to separate the numerator, we have to apply the formula of sin alpha minus beta, where alpha is 5x and beta is 3x, which is sin alpha cos beta minus cos alpha sin beta. So let's use our formula. So we will get sin 5x cos 3x minus cos 5x sin 3x. And let's give individual denominator. Now our first term can be simplified as sin 5x cancel out, and cos 3x upon sin 3x will become your tan 3x. Similarly, in second term, sin 3x will cancel out, and cos 5x upon sin 5x will become your tan pi x. Now just apply the formula of integration of tan 3x, which is log mod sec 3x upon coefficient of x, which is 3. Similarly, integration of tan pi x will be log mod sec pi x upon coefficient of x, which is 5, plus c, which is given in option C. Ta-da! મસ્ત ગૂગલી સમજ્યા. ગૂગલી એટલે આમ હું સમ સોલ્વ કરાયા પછી તમને આમ શરમ આવી જશે કે સર ऐसा कुछ हो सकता है. જો in this question we have to integrate pi raised to x plus 1 e raised to 2x minus 1. Here you should observe we have variables are in power. So let's simplify our question. Pi raised to x plus 1 can be separated as pi raised to x into pi raised to 1. Similarly, e raised to 2x minus 1 can be separated as e raised to 2x into e raised to minus 1 dot dx. Now, pi raised to 1 and e raised to minus 1 is constant. Take it outside of the integration. We just have to integrate pi raised to x into e raised to 2x. Now, let's try to take x, which is in power, common. So we will get 5 into e square dot dx. So here we have constant raised to x, or we can say box raised to x, so which can be easily integrated using the formula of integration of a raised to x. So it will be a, or we can say our box raised to x upon log mod a, which is pi into e square, plus c. To get the final answer, you have to separate the terms. We will get pi raised to x into 1 will become pi raised to x plus 1. Similarly, e raised to 2x into minus 1 will become e raised to 2x minus 1 plus c. In denominator, we have log a into b, which can be separated as log 5 plus log e square. And according to the property of log, we can take this 2 within the multiplication of log. So we will get 2 log e, or we can say pi raised to x plus 1 e raised to 2x minus 1 upon log 5 plus 2, because log e is 1, plus c is your final answer, which is given in option C. Ta-da! Here we have to integrate sec x plus tan x the whole square. So let's simplify by opening the bracket. So here we'll get sec square x plus tan square x plus 2 times sec x into tan x. Yeah, we can integrate first and third term, but to integrate tan square x, we have to convert into sec square x. So let's say if sec square x is as it is, tan square x can be converted into sec square x minus 1 plus 2 times sec x tan x will also as it is. The sec square x plus sec square x will become 2 times sec square x. Now we are ready to integrate. In first term, 2 will be as it is. Integration of sec square x will be tan x minus integration of 1 will be x. And in last term, 2 will be as it is. Integration of sec x tan x will be sec x plus c. And to get the final answer, we can take 2 common from these two terms. So we will get 2 times tan x plus sec x minus x plus c, which is given in option A. Ta-da! here we have to integrate x minus 1 upon x plus 1 the whole square, which is in the form of emx upon ax plus b whole raised to n. So let's assume our non-expandable term, which is x plus 1, is equal to t. So we will get x is equal to t minus 1, and if we differentiate both the side, we will get dx is equal to dt. So we can modify our integration as, instead of this x, we have to substitute t minus 1 minus 1 upon x plus 1 the whole square will become t square, and dx will become dt. So here this minus 1 will become your minus 2, and if we give individual denominator, in first term we will get 1 upon t, and in second term we will get 2 upon t square, or we can say t raised to minus 2. So we are ready to integrate. Integration of 1 upon t will be log mod t minus 2 will be as it is. Integration of t raised to minus 2 will be t raised to minus 1 upon minus 1 plus c. To get the final answer, just substitute the value of t. So log mod t will become log mod x plus 1 minus minus become plus 2 upon t, which is your x plus 1 plus c is your final answer, which is given in option A. Ta-da! આનો ક્વેશ્ચન યાદ છે, ટેક્સ્ટ બુક નો જ છે. શું કરતા હતા આપણે? cos 2x ને સિમ્પ્લિફાય કરવો પડતો, કેમ કે બીજા બધા એંગલ સેમ છે. તો cos ડબલ ધી એંગલ ની કઈ ફોર્મ્યુલા યુઝ કરવી પડશે? અહીં સમેશનમાં 2 sin સ્ક્વેર વાળું છે, તો આપણે 1 minus 2 sin સ્ક્વેર યુઝ કરીએ તો ચાલે. So 1 minus 2 sin square x plus this 2 sin square x will be as it is upon cos square x dot dx. So 2 sin square x will cancel out. We just have to integrate 1 upon cos square x, which is basically sec square x. The integration of sec square x will be 10x plus c. Option C. Ta-da!